The last lecture of cognitive psychology is about how we can link the understanding from psychology into computer science. That's why I'm working in 7 years in New Zealand as part of computer science discipline to teach psychology. So cognitive psychology is basics for AI, artificial intelligence. So when we understand human intelligence, we can make what? We can make what? We can make computer intelligence. That's the dreams in last 60, 70 years of human cognition studies. Right? Of course, I will talk about this topic in due course. Before we taking on, as usual, we have 2 quizzes. From next week, we don't have any use for cricket. We don't have any quiz from next week, which is your favorite, but you don't have. Okay, so that is last cricket quiz. Right, so be patient then. Okay, there are 2 questions about language structure. And the first question is about language structure in terms of language determinism. The language determinism means language is depending on thought. Okay? So who said first? Which of the following cognitive psychologists is most closely associated with the theory of linguistic determinism, which state language strongly influences the way that a person perceives the world, such as the tribes, some of the Indian tribes have many names for certain object, right? Eskimos has many names for snow. Okay? Some country or some tribe only use 2 colors name. Many of other natural language has 11 color name. Okay? Which of the following psychologists is talking about linguistic determinism? Pinker, who wrote about language instinct, Chomsky, popular name, and Wolf, okay, and Watson. Okay, get it? Right. Oh, very good. Yep. Wolffian theory, Wolffian hypothesis. What the Wolffian says, so language is determined. Because of the language, our thought is limited. So that is hypothesis of linguistic determinism. No, not Chomsky. Chomsky is more about modularity. Cognition and language is different. That's what he claimed. Okay, second question. Right, that is talking about the modularity hypothesis. Which of followings properly summarize modularity hypothesis of language processing? Okay, number 1, language and cognition are functionally different. Number 2 is language area in the brain are distinct and perform only one type of processing. Number C, language functions such as phonology, semantics, syntax are all performed in separate steps in speech production. Number D, the lexical element, that is noun or verb, are stored separately in memory throughout the brain. So modularity is what? What is the hypothesis of modularity? So one of the main supporters for this theory is Chomsky. Okay. Get it? You get it? Right. It's a bit. Yep. Language and cognition is functionally different means modularity. Huh? Did I? Sorry. Okay? So that is the answer. Modularity is supported by the Noam Chomsky say our language and cognition might be different thing. So that's why Noam Chomsky proposed the language acquisition unit. Okay, thank you very much. That is the last session of your cricket quiz. And at the end of this lecture, the staff from the education unit comes in to interview you guys or survey. Someone comes in and they survey you. They will give you some questionnaires about your feeling about cricket. So your satisfaction of cricket news. So they will survey you. So feel free to join them. Okay. Right. That's it. Right. As I said, this one is the last lecture of cognitive psychology. So that's why I particularly choose this one. Should be very useful to understand how the cognitive psychology is linked to computer science. Neural network, genetic algorithm. So probably many of you heard about this particular technique being used in industrial engineering. Many of the optimization tools. So that's why you have to understand cognitive psychology and then how human has a reasoning, problem solving. That is called intelligence, how we can make intelligence on computing system. So I'm trying to give you some history of starting of artificial intelligence. Okay, first one, Deep Blue. You know the Deep Blue? Deep Blue is IBM computer. It's kind of supercomputer, right? The main idea of why the IBM want to make Deep Blue was make intelligence. Okay, so before that time, the computer science history is they want to compete against the human being. Human being is much better than computers in many aspects, right? So the computer scientists, their dreams were something like how we can make human-like computer. Human-like computer. That's why human intelligence study or thinking process is the major part of our process. So in our world history, first time in 1997, around 14 years ago, the Deep Blue won over Garry Kasparov, the chess master. Before that time, they had a couple of tries, last 5 years, like 91 to 97, 96. The Garry Kasparov is won all the series. The first time in 1997, computer win over human being, first time. Of course, this Deep Blue has many pattern and knowledge, structure of chess playing, and they have to search it. Okay, but human is very strictly. Last in our cognitive, our textbook, chapter 10 is about chess experiments. Say the chess master memorized the patterns rather than each individual move. That's how humans solve this problem. But computers cannot do such a thing, so they have to have full search of every movement. Okay? The point is how fast the computer can be. So Deep Blue doesn't have any big intelligence. That's only concerned about how quickly they can process all the patterns in chess playing. But that is pretty much pivotal moment. Say, well, now computer can win over the human being. So that is kind of very important idea. So why people doing that? Say, we're starting from some of the history. Turing machine, Turing test. You know the Turing test? Turing test is very important concept in computer science. Okay, so when we had the first computer, many scientists believed, computer looks good. Computer looks like human being, but how we can say computer has thinking power? Computer has an intelligence. Okay, so Turing firstly proposed that his test is this one. If human cannot tell whether the response is come from computer or human being, we can say that computer has intelligence. So if A intelligence passing through this Turing test, we believe computer has intelligence. So from 1950 to 1970, many of the computer scientists is trying to make artificial intelligence with language structure with language structure, at this point, with the language structure, it looks like human being. One of the example is this one, Eliza. Right, Eliza. Oh, so what do you want to ask? Who are you? Okay. You can talk with Eliza. Who are you? Who do you, if I were not? Okay, it's okay. I am. I asked, I am Ho-kyung. I answered, I am Ho-kyung. We're discussing you, not me. Okay? Okay, I have a problem. Eliza says, don't ignore this one. Okay, I don't know why that happened. So, please go on. Okay. So Eliza say, please go on. Just ignore this part. Okay. I love with a boy. Can you elaborate on that? Can you add more? His name is YJ. I'm not sure I understand you fully. Oh, okay. I love with YJ, so okay. Any questions such as, if I am loving with a boy, what will happen? It takes time. If you have a very difficult question to Eliza, they are thinking more. You believe I can speak Chinese, do you not? If Eliza cannot understand the question, they just passing the sentence to believe like you are not speaking the same language with me. Okay, so make a simple question, like, what time is it? That is very clear. Okay. This is quite positive. See, Eliza, this was first proposal in Eliza 1960. So when you ask a question to Eliza, they will answer back to you. But that using only language structure is kind of faking system. But that pass the Turing test. That looks like human intelligence, right? So since then, there are many of the chatbot. If you search chatbot, we have more advanced version of chatbot. So you can enjoy it just alone, the solitude. So if you need a friends, you can chat with this chatbot. So many of the chatbot, the basic engine and inference rule is using language structure. So they will make answer based on your question, tweaking it. Okay, such as, so that's why you have to know what is the Turing test. And Perry, so one of the things is Eliza is using language structure, Perry is using different terms. So one of the experiment is done by talking between Eliza and Perry. So without any human intervention. So they talking, keep talking each other. Eliza say something and Perry say back. They're using this Perry's question, Eliza answers back. So this one is keep it going. So that could be really interesting experiment, but that is kind of what the meaning of the Turing test. So, intelligence. So that's why we need two prominent researchers in AI. Of course, cognitive psychology we learn in chapter 9, reasoning, Alan Newell and Simon. Okay? They wrote this book, Unified Theories of Cognition. Okay, in this book, already you learned from chapter 9 three things. We learned about general problem solver, Minji analysis. What they said is physical symbol system. So that's why I want to explain why AI is based on the physical symbol system. Okay? Right. Simon and Newell claimed symbols are patterns. If all the knowledge or all the thinking process can be pattern with physical symbol, we can process it. Okay? So we don't know exactly, but what the Simon and Newell proposed is, if that is space, problem space, if it can represent any knowledge in physical system, okay, or symbol thing, likewise, if that is what we want to process, we can make intelligence. Okay, computer can be programmed to think with physical symbol system. What they assumed, Simon and Newell assumed that human knowledge is a physical system, physical symbol system. We don't know how it made, but probably all the knowledge, all our thinking process are physical symbol system. That's why we can store, we can input, we can output. That is basics of computer system. That goes the memory in computer architecture, keyboard and mouse, and screen. Who proposed this one? Paul Neumann. Based on physical symbol system. And Simon and Newell. Okay? So point is this one. Human mind is a physical symbol system to input, output, store, modify symbol structure, and carrying out some of these actions in response to symbols themselves. So their dream was, the Simon and Newell want to modeling all the human knowledge in physical symbol system. That's what they dreamed about. That's why Simon and Newell had something unusual approaches. Protocol analysis. Okay, Simon says, that's Simon, that's Simon. Herbert Simon say, understanding thinking is impossible because we don't know at the time, 1960, 1950, up to 1980s, understanding thinking is impossible. Instead, he believed that we can understand the task and problem. We can understand the task, job. Okay? That's why Simons is the father of human-computer interaction. Simon say, we can't make a thinking process. We can understand the thinking. So he proposed that we have to start with task and problem solving. That goes purely into artificial intelligence. That goes into human-computer interaction. How people perform the task. If we can understand how people perform a task, we can make better system, better interface. Okay, that is what task analysis is needed. And for the problem solving space, they are focused on the logic behind it, the algorithm behind it. So they are focused on intelligence algorithm, such as neural network. So Simon says we can't understand thinking, so instead we can understand the task and problem. So his main concern is how to solve the problem with physical symbol system on which the operation can work. So they want to render, they want to depict whole the system with the physical symbol, and then they can operate. So I put this physical symbol in here, this one and there, something like operation, plus minus, multiplication, modifying. Okay, that's what they dreamed about. So this one is sequence of human knowledge. So if someone wants to solve the problem, we have to rearrange this one likewise. That is only way to solve a problem. So this one is what Simon says. We have to depict all the system with physically, and then certain operation work on this particular symbol. That is their assumption. You like assumption? Yeah. Production management or there are many assumptions, right? Because we can't handling all the problems, so we make a certain assumption. Likewise, that's what Simon says. So, point is, at his first step of human problem solving, he conducted protocol analysis. Protocol analysis. I can work with you guys. What is the protocol analysis? That is very cunning, okay? So protocol analysis is being used in introspectionist. You remember the introspectionist? In chapter 1, the history of cognitive psychology is introspectionist. Very early stage, we can't understand the thinking process in psychology. The only way to understand the thinking process is make them speak. While they are thinking, you have to make them speak. Keep speaking while they are talking, or while they are thinking. So that's the introspectionist first approach in psychology at that time. And another historical event happened in 1926, Gestalt psychology, using also the protocol analysis. And Newell is claimed that artificial intelligence can be made by task analysis from protocol analysis. We show that. Okay, that's what they did. Okay, look at the question. This is a problem in cryptic arithmetic. In the expression, okay, point is there are 10 letters. There are 10 letters, and each letter representing one digit. Okay, each letter has a different digit. The problem is to discover what digits should be assigned to each letter, so that when the letters are all replaced by their corresponding digit, the arithmetic is correct. So that is the thinking aloud method. So that is participant, okay, that is situation, and then they ask to all the participants, say, please speak loud, all than you are thinking, as you attempt to solve the problem. Ask them, keep talking to see what? How they solve the problem. That is the only way, isn't it? If they are talking, what they are thinking is the only way we can detect how these particular people are thinking, right? So you may write down anything you wish. So point about think aloud method is this one. Speak aloud while you are thinking. Question is this one. Okay, there are 6 letters in each one, Donald and Gerald, and that is Robert. And first given is D equal 5. And from now on, who want to play with me? Who want to play 창호, 동호, 창호? Okay. 창호, you want to play with me? Okay, you have to solve it. Show me. Keep talking. Keep talking. So first one, D equal 5. D equal 5. D equals 5. You're talking. Keep talking while you're thinking.
Okay.
Oh?
Okay.
Oh, only about this one. Don't talk about your girlfriend. Okay? Talk about only the problem. So D equal 5. How you solve it? Start. I mean, you need slowly. So D equal 5. First one. Okay? Okay, D equals 5 equals to 5. Keep talking. Just talking when you're thinking. You don't know? Who's on the play? Stephen? You want to talk with me? Okay, so D equal 5.
Yeah, first I'm thinking about how I can, put for every D 5.
Okay, first. Okay, hang on, slowly. Put 5 for every. Okay.
And for example, at the last,
Okay, for example, hang on, for example, that's why you need the tape recording. Okay, for example, put the 5 to the last digit. So, such as do, 날, 5, 제, 날, 5, okay? Sorry. That's it? And then
think how compared to the first D and G.
first D and okay. This one.
But I haven't the solution yet.
Oh, of course, it's just talking while you're thinking. And then you want to change this one?
Yes.
Okay, so also change first D with 5. So it changed into this one. Okay? And then? That's it? That's it? 동기, take it. Continue. 5 and 5. So you wanna add up? Okay, so add up last digit. Okay, so 5 plus 5, 10, isn't it? Okay, so next thought.
I think A, B, C, D.
Oh. 4 plus 1. Where is 4? 4 plus 1?
Match the number with match the
Match the letter
with the number.
with. Okay, how? Okay, such as D equal 5 means sequencing. Okay. So okay. So 동기 sequencing. So I guess D equal 5 means A equal 1. A, B, C, D. No. A2, okay. C equal, B equal 3, something like that. So, and then match it. Okay, so D5, or something. Okay, some number. Okay, likewise. This one is a number replaced by the number you're sequencing. Okay, so that is your thinking. You can leave it as it is. Who is it? Junan. Yunan, sorry. Yunan. So 5 to the power is 10. 5 plus 5? So you may guess T?
Yes.
Okay, so guess T equals?
0.
Yes. Okay, right? And then? What is the next note? So 1 is carrying on. The carrying 1. So okay. Now next one is 1 plus 2L equals what? R, right? Okay, so next note. R must be odd number. 홀수. Isn't it? Yeah? R must be odd number. Am I right? Because every 2 times plus 1 make odd. 홀수. Okay? So, likewise, this one is keep it going. This kind of thinking process keep it going while you're talking. So, point is this one. At any time, if you are not using your thinking process, computer must search 362,808 cases for matching between number and digit, like what Donggi did. No, sorry. I'm not saying you're stupid. You say your idea is very similar with computer approach. Okay, mapping everything. But that is important. I will come back to your point later because your point is really important to understand the human decision making. So for the computer processing of this simple cryptic arithmetic, they have to search 360,000 cases. But while you're doing this one, as Donggi did, Donggi is the key point in here. He used the heuristic. Comes from his experience. Probably he had many experience to guess at this point rather than to find this more logical way. That's the human. But computer cannot do that. That's why computer must search 360,000 cases, but human had the better in here. That's why Kasparov is better in playing chess rather than computer. He used the heuristic. Okay, that is one point we can guess from this protocol analysis. And second thing is, human do this one. We can't solve the problem in a one shot. Okay? To make safer calculation or safer implementation, we divide question into sub-goals. So in here, that is a major goal. That is the top goal. Top goal is answer the question. Okay? And find the question. Find the answer. That's why second step was this one. Starting from put the 5 in here to identify t. Okay? Goal is in here, and then they divide and conquer. Okay? Divide and conquer. So that is goal, sub-goal decomposition is the way our human beings solve the problems. That's why mean change analysis comes from. Mean change analysis is about goal, sub-goal decomposition, and every sub-goals we define the action. Okay? Goal, sub-goal. Okay? After that, when you have a sub-goal, you can define the action. That is basics of human-computer interaction. You have goal and sub-goals, and you define the action, such as send text messages. What is sub-goal? Go to the menu. Huh? You have to find the icon, right? And then your action, click. That's how your interface design, goal, sub-goal decomposition, and finally action system. Okay, that's why you understand Simon and Newell is the father of HCI as well as father of AI. That's starting from goal, sub-goal decomposition, and that is about protocol analysis. Okay, likewise, we have put the 5 at the end, so t must be 0. Okay, and 2l plus 1, that is carrying in here, so r should be odd number. Also, r should not be 5, okay, because d already 5, so already taken by, so r should be 1 or 3 or 7 or 9. At that point, you can put the numbers in it. That is what Dongis did. Heuristic. Much faster than computer sometimes. Because we can use the heuristic. So certain times, human intelligence, what Simon and Newell identified, in certain times, people do search, and then in some point, they use the heuristics, experience. So he wants to make these kinds of intelligence problem-solving approaches. So Newell and Simon found that people break the problem down to goal, sub-goal decomposition and try to find the actions at each step. So people vary the problem-solving strategy, but heuristic permit the people to cut the problem space into smaller components. So when you're using heuristic, we don't need to search everything. Okay? So only some part of it. See? Computer need to search all of them basically, but human can only search the space, much smaller space, if he can find the best solution in here. That's why AI is looking for how it can be look like human approach, but it is really hard. That's why Minji analysis, Minji I already explained this one likewise this way. Okay? Minji analysis means starting is this one. That is situation. Jenny is at home, state. My goal is I want to take Jenny to school. Ending state is Jenny at school. Okay, that is problem space, the distance between start and ending state. So your next goal is how to get there. So your action is I need to drive her there. Okay? However, battery is flat. Battery is dead. So I need a new battery. So where I get the battery? The auto repair shop. How to get there? On foot, because the car is not working. So Minji analysis is kind of, that is our goal, and then sub-goals, and how this sub-goal can be accomplished by the action is defined, so the computer can search this Minji analysis, okay? A computer can modeling all the problem space with Minji analysis to find the solution. Get it? So that's why since AI is looking for expert system. The expert system is a very simple one. Okay? Computer program that can perform the way an expert does in a fairly specific domain. So simply say we put the rules. The AI is if-then rule. So you probably in the programming language you use many of the if-then. If A is bigger than B, to calculate A times B, right? So this production system, we call this one is production system. This production system is the main part of artificial intelligence. Of course, if-then rule cannot interpret all the human knowledge, but they can cover many parts of it. That's why expert system using AI on what? If-then rule. If-then. Production system. One of the oldest example is the mycin. Okay, that has 500 if-then rules and dealing with about 100 different kinds of bacterial infection. It's being used in the medical system. One of the example of being used in the mycin is this one. That is condition and suggestion. So that has a rule, so that if you type in some of the symptoms of your patient, okay, they can suggest to you there might be what? So that is, it's not probability, it's confidence. Never mind. I mean, it looks like probability, but I mean that is kind of, okay, the confidence level to define when this symptom happens, they can suggest it. If-then rule. We are not using such a simple if-then rule anymore. So many of the expert system now is being designed by other AI technique, genetic algorithm, machine learning, neural network. So we developed many of the technique. Borneo is one of them. It's true. Borneo is one of them. And K-star algorithm. Any algorithm you talking about? A-star algorithm. What is the other thing? Algorithm. You taking the algorithm course, right? Any other algorithm? A is the LP. LP is one of them. So some people are using the LP to optimize the solutions. Okay. So the outcomes say this expert system was better than medical students at that time. So now it's talking about the last section of this AI is about criticism. So some people say, okay, there's an interesting part. So I don't know whether you agree with me or not, but many of the people is claiming that AI is not the way we have to go. So one of the criticism is this one. Computers must have serial processing, but that is not true anymore. Okay, now computer can do the parallel processing, but in 1980s, 1990s, most of the computer design is single process. Okay, but now it's multiple. So many people say human do parallel, but computer only can do the serial. So it's not the way we have to go. Very minor claim. So that's why neural network. Okay, some of the neural network can avoid the problem of serial processing. Okay, so you know that neural network? Anyone heard about neural network? Algorithm? It's not teaching the neural network. Simply say, so this one is case, every data, okay, the data you have, and then that is your output. For example, this one, you have a heaps of data of insurance policy, whether people have claimed or not, okay? So you have heaps of data of customers, such as their age, their job, their salary, their family structure, okay? You have hold this large amount of data, so person A's data, person B's data, in terms of age, gender, or whatever that is, and then that is kind of outcome, whether this person had claimed any insurance or not, okay? You have thousands data, and then you have thousands of the outcomes, okay? And then they just mapping it, the neural network. Using a neural network, they found that the weight of the layers. So for example, what outcomes say like this one. If the age is 45, if the gender, there is no particular issue about health, they never claimed. They never claim any insurance. However, if the age is more than 65 and no job, they will claim the insurance. So you can use the neural network model with heaps of data. You can expect, you can predict the outcomes. So parallel processing can be done with neural network. So neural network can avoid one of the criticism of AI. You should learn this technique. Anyway, you see that is simple approach. So, okay. The second criticism about AI is intuition. We can model intuition. Computer can model very simple logic, but how computer can modeling intuition? So genuine expert, they cannot reveal their knowledge anymore, right? So that's why the problem thinking about absence of intuition is one of the limitations of AI. Example is this one. I just write down somewhere in here. Okay, in 1983, the Lockheed Martin DC-100 has landed on the airport, but there's a 3 engine was broken, so nobody can handle it. In particular, the safety system, the transport, the telecommunication headquarters cannot solve this problem. But the crew member, one of the captain, is safely landed on this particular aircraft to save two-thirds of passengers. The reason why they do that is they're using simple intuition, gliding. Okay, computer search it cannot find gliding because that doesn't have any rule, that kind of rule in the system, right? But human has a gliding system. Okay, they just thought about gliding intuitively. So that's why they says it. Computer cannot generate this kind of intuition. So that is, intuition can be, but some people say intuition can be modeled, but still it's a limitation. Another thing is independent thinking. Computer cannot do independent thinking because they only do what we gave. So we cannot call this one is intelligence, some people say. But there's other counter example, like Mars rover. You know that? So this kind of machine is in Mars now, keep working at this time, but that has intelligence with independent thinking. They decide by themselves what they have to do. So that is kind of counter example of people, the computer cannot do independent thinking. This one is the last criticism about AI. So human intelligence can enhance another intelligence. We can make better intelligence more, but computer cannot do that. Such as Sears paradox. Sears paradox is this one. Okay? So imagine that you are locked in a room. You are given a large batch of Chinese writing to translate. You never know any Chinese letter, but you are given a set of rules for translating Chinese into English. And you are given a set of rules for formulating response to questions that were raised in the first batch of Chinese writing. So, in certain time, in time past, you can translate every Chinese in English because you have a rule. But you never know Chinese. You only know the rule. So people say, is that the artificial intelligence is real human intelligence? Okay, you know only set of rules, isn't it? So that is kind of still debating whether people can call this one is real intelligence or not by themselves. Okay, that's the everything about AI. Still debating, so many of the AI technique is using many technique tools, okay, like neural network, genetic algorithm, A-star algorithm, or LP, or Voronoi, whatever that is called. They're trying to find how human can, and how computer can be like human intelligence. Expert system is one of them. Okay. Right, that is all about the important aspect of cognitive psychology, and my suggestion is if you're interested in cognitive psychology, that is basics for next year, Professor Park, Min-Young Park's HCI in first semester. Okay, so you can take it, or I'm trying to teach you guys decision theory and behavioral economics in next year, first semester. So that is kind of relevant with human factors and cognition and HCI thing. That is the end of last one, and tomorrow we don't have any lecture.